Hi guys, today we're going to talk about geometric sequence and series. This will be our last video for the semester, and I'm glad you guys made it all the way to the end. So let's get started. First, let's go ahead and define the geometric series. So the geometric series has the formula. It looks like it's based off the sequence, just like the arithmetic. And you can find that on page 795. And the first term is the letter A. And then geometric, instead of adding, we're multiplying by some common ratio. R is the common ratio. Okay. So, the formula for it, if you look on the sheet, on the page 795, you'll see that the last term is going to be a times r to the n minus 1. Right? Because the first term does not have an r, so the nth term has one less r. That's kind of the way to think about it. So, and then of course we'll talk about some geometric means, the sum of the geometric series, and also the dealing with the infinite geometric series. Okay? Alright, let's go ahead and get started. So, write the first 5 terms of each geometric sequence. So first thing first, what you end up having here is you have a summation notation here, but we're just going to go ahead and use that to write the sequence instead of finding the sum. So we're starting at 1, and this is an infinite, so notice the infinity symbol, and the negative 3/4 n. So start out with n equal to 1, so which means when n equal to 1, we have negative 3/4. When n equal to 2, we get negative 3/4 quantity squared, which is 9/16. When n equal to 3, we have negative 3/4 to the third power, which is negative 27/64. And when n equal to 4, you got negative 3/4 to the fourth power, which is 81 over, let's see, 256. And when n equals 5, you have negative 3/4 to the fifth power, which I believe is negative 243 over 1024. Okay, so the first five terms of the sequence: negative 3/4, comma 9/16, comma negative 27/64, comma 81 256. Comma negative 243 over 1024. Okay. All right. So in this case, right, this is our first term, and our common ratio, right, the number we multiply every single time is negative 3/4. Right, because this is technically AR squared, AR to the third power, AR to the fourth power. Okay, all right, let's go ahead and move on to the next one. All right, this time it did us a favor. They just gave us an A1 equal negative 1/2, and R is negative 1/2 also. Okay. So in this case, first term obviously is negative 1/2. So the second term, negative 1/2 times negative 1/2. So that is 1/4. Third term, negative 1/2 times negative 1/2 squared. So that is negative 1/2 times 1/4, which is negative 1/8. Fourth term, negative 1/2, negative 1/2 to the third power, which is -1/2 times -1/8, that is 1/16. And the fifth term, -1/2 times -1/2 to the fourth power, so that's -1/2 times +1/16, which is -1/32. So geometric sequence in this case will be -1/2, comma 1/4, comma -1/8, comma 1/16, comma -1/32. Okay, pretty straightforward. Listing out the geometric sequence, it's not too bad if you're given the A and R. Now you might need a calculator for it sometimes, but most of the time you probably don't. The fraction button is always a good thing on the graphing calculator to know, just because it's much easier to write as a fraction. So, okay. So let's go and move on to number 3. Number 3, we need to find the specified term of the geometric sequence. So we're given the first 5 terms. Here you got 162, 54, 18, 6, 2. So that's A1, A2, A3, A4, A5. Okay. So we want to find the 8th term, right? But the thing is, in order to find the 8th term, we need some more information. So think about the formula A sub n equal A times R to the n minus 1. So if we take all the information that we have, right, this A, remember, is A1. So what we know right now is A sub 8 equal 162 times R to the 7, right? Because in our case, n equal 8. Okay, but this is not going to help us because we don't know what R is. Right? We need to know what R is. So in this case, let's find the common ratio first. And with the given terms here, we should be able to identify a common ratio relatively quick. Okay? I think you can pretty much tell that the common ratio is 1/3. Right? They're dividing, because if you look at the number, they're dividing by 3 each time. So A sub 8 is going to be 162 times 1/3 to the 7th power. And I'm going to use a calculator for that because I have no idea what that is. 3 to the 7 is 2187. So this is 162 over 2187. And I'm just going to double check to see if that can be reduced. And this actually reduced to 2 over 27. Okay. So the 8th term is 2 over 27. Okay, we got to make sure that we have the first term and also the common ratio. If we have those two information, we'll be able to find any term that we want. Okay. All right. Part B, find A sub 10. So the 10th term, given that A3 is 16 and A7 equal to 1. All right. So again, we're trying to find the 10th term, but in this case, we need, that's not what I meant. Sorry guys. We need A1 and R. Okay, so this is the method that we're going to use. We're going to use both of these information and we're going to set it up. So let's check this out. So we know A3 is 16 and that is also the first term times R raised to the 2nd power. Right, per our formula. We know that A7 is 1, which is also A1 times r raised to the 6. Okay, so what we're going to do is, so what happens if I have, so what happens if a3 divided by a7? Well, if I have a3 divided by a7, that means 16 divided by 1, that means a1r squared over a1r to the 6. Okay, and then, well, check this out. We can actually do a lot of work here. We can go ahead and do some cancellation. So, which means we got 16 over 1 equal a1r squared over a1r to the 6. The a1s will cancel, so I get 16 over 1 equal r squared over r to the 6. And here we can reduce. This is 16 over 1 equal 1 over r to the 4th power. So this means that r to the 4th power equal 1 over 16th. And raise both sides by a 4th power. You get r equal 1/2. Okay, so you r equal to 1/2. Right? Once we know r equal to 1/2, then what can we do with that? Then we know, if you look at the second equation right here, 1 equal a times 1/2 to the 6th power. So 1 equal a times 1 over 64, which means a equals 64. So if we know a equals 64 and r is 1/2, we can go ahead and figure out what the 10th term is. I probably should use a different page. Learn next time. So which means a sub 10 is going to be 64 times 1/2 to the 9th power. So 64 over 512. And 64 divided by 512 is 1/8. And we're done. Okay, so as long as we have two terms in the geometric sequence, we'll be able to figure out the formula and find out and be able to find the specific terms. Okay. All right. Now let's go ahead and talk about the partial sums and the infinite sums. Okay, so for the partial sum, the sum of the first n terms of a geometric series, this is the formula that we'll be looking at. The partial sum of the first n terms is a minus ar to the nth power over 1 minus r. And in this case, r does not equal to 1. Okay, so in this case, r does not equal to 1. Now, one way to think about this is if r equal to 1, right? That means your a AR, AR squared, AR cubed, and so on is basically just going to be A. And this is no longer geometric. This becomes a arithmetic. Right? So that's the reason why R cannot equal to 1. And also the way the formula is derived, when you plug in 1 into here, you have 0 on the bottom, which is undefined. Okay, so that's the reason why the R cannot equal to 1. But other than that, anything goes. Well, besides imaginary numbers, obviously. Okay. So let's go ahead and find part A. Let's go ahead and work on part A and see the partial sum of the geometric series. Okay, so first thing first, again, the A is still the first term. So A in this case will be negative 3/2, right? And then we just got to figure out what is R. Now, hopefully you can notice that the sign alternates, right? The sign alternates means R has been negative, right? Alternating signs means R is negative, so we know that for sure. Okay, so now we're just going to figure out, well, what is, besides being negative, what is our R? And notice the numerator is always 3, but the denominator, right, looks like it multiplied by a factor of 2. So I believe that R in this case can be negative 1/2. Okay, so to find the partial sum, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms, so our n is going to be 9. So the partial sum formula will be S of 9 is negative 3 over 2 minus negative 3 over 2 times negative 1/2 to the 9th power over 1 minus negative 1/2. Okay, so this is negative 3/2 minus negative 3/2 times negative 1/2 to the 9th power is negative 1 over 5/12 over 1 plus 1/2. Okay, so really quick, let's see what we have here. So this is negative 3/2. Let's see, minus negative minus 3 over 1024 over 1 plus 1/2 is 3/2. Actually, I'm running out of space. I have very poor space management. I'm going to punch the numerator in the calculator just so to save some time. So negative 3/2 minus 3 divided by 1024. And this is negative 1539 over 1024 divided by 3/2. So divided by 3/2. I end up getting negative 513 over 512 as the sum. Okay. So yeah, so I end up getting negative 513 over 512. Now this one right here is your partial sum. Okay, so the partial sum formula is fairly straightforward. Can get a little messy because you had to raise the r to the n power. But depending on the values, sometimes this might look a little messy, but sometimes it could be pretty straightforward. You just never know. Okay. Alrighty. So let's go ahead and move on to the next problem. This one's pretty nice. So you got a1 equal to 5, r equal 1/2, and then we have n equal to 6. So this one's pretty straightforward. 5 minus 5 times 1/2 to the 6th power over 1 minus 1/2. So this is 5 minus 5 times 164 over 1/2. I'm going to punch the top in the calculator. Excuse me, 5 minus 5 times 1 over 64. This is 315 over 64 divided by 1/2. So that becomes 315 over 32. And then we are done for this one. Okay? So again, pretty straightforward. Plug it in. Alright, now let's talk about the infinite sum. So the infinite sum formula actually derived from here. Actually derived from the partial sum formula. Okay? Alright, and so this time what we want to do is that let's go ahead and derive the formula. So for example, I'm sure you can see that we can factor a out. Okay? Now, for infinite sum, there is a restriction. So what happens if r is between 1 and -1? Okay, so if r is restricted between 1 and -1, what happened here is you're talking about, so when the number, so when the r is raised to the nth power, right, when r is raised to the nth power, right, this r is still going to be between -1 and 1. In fact, r to the n is going to approach 0. Right? Because if you think about it, if you take a 1/2 raised to a huge number, so let's say 100, the value is going to get very close to 0. Okay, so that means if we let n goes to 0, goes to infinity, that means the 1 minus r to the n part, that means this part is going to get close to 0. So therefore you get a times 1 minus 0 over 1 minus r, and you get a over 1 minus r. That's the infinite sum. Okay, so that's how they came out with the formula, right? But then the stipulation is r has to be between 1 and -1. Alright? Okay, so knowing that, let's go ahead and move on. So we know the infinite sum is a over 1 minus r. So let's go ahead and look at our part A. Part A, we have a over 5 plus a over 25 plus 8 over 125 plus ... So we know the first term is 8 over 5, and hopefully you will be able to recognize that the r is 1/5 because you multiply 5 on the bottom each time. Okay, So the infinite sum is going to be a to the 1 a over 5 over 1 minus 1/5, which is a over 5 divided by 4/5, a over 5 times by 5 over 4. So the answer is 2. 2 is the infinite sum of this particular infinite series. Okay. Part B. Now, part B, I threw you a little bit of curveball, right? So we know A2 is 6 and the R is 2/3. So that means A2, remember what is A2? A2 is AR, right? So that means we know 6 equal A, the first term, times 2/3. And that means the first term is going to be 3 over 2 on both sides. 9. So once you figure out the first term, the infinite sum is going to be 9 over 1 minus 2/3, which is 9 over 1 minus 9 over 1/3, and that is going to be 27. Okay. All right. The third set is a little bit of a needs a little bit of property. So if you recall from the previous section in 8.3, it tells us that if we have a summation of a function minus another function, we can separate it. Okay, and this I believe is on page. Actually, not 8.3. Sorry, it is on. Yeah, it is on page 783, section 8.2. 783, 8.2. This says that I can go ahead and split them up. Okay, so let's go ahead and deal with them separately. Now, you need to be able to do a little bit of rewriting. You need to recognize that this is the same as one over 2 to the n is the same as 1 to the n over 2 to the n, which means by using the exponential rule, this is 1/2 to the nth power. Okay, so that means if n equal to 1, the first term you get is 1/2, and your multiplier in this case is also 1/2, because you multiply by 1/2 each time. So that means this infinite sum will be 1/2 over 1 minus 1/2. So you get 1/2 over 1/2, which is 1. Okay, and we can do the same thing with the 1 over 3 to the n. Right? So that means a little bit of side work. 1 over 3 to the n is the same as 1/3 to the n. Right? Similar rationale from above. So which means if n equal to 1, you get 1/3. And the ratio in this case is going to be 1/3. So the sum for the second infinite series is going to be 1/3 over 1 minus 1/3, which is 1/3 over 2/3, which is 1/3 times 3 over 2. And that's going to give you 1/2. So our final answer is going to be 1 minus 1/2, which is 1/2. Okay, so yeah, so there's different type of problems that you come out with the geometric series, but as long as you know how to find the sum, you should be all right. Okay. Now the next part, the geometric series can also be used to change the repeating decimal to fractions. So check this out. So if you get 0.222222222, what you need to think about is this is the same as 0.2 plus 0.02 plus 0.002 plus 0.0002 plus ... Right? And notice we can factor a 2 out of it. 0.1 plus 0.01 plus 0.001 plus 0.0001 plus, and so on. And notice that this is the same as 1 over 10 plus 1 over 100 plus 1 over 1,000 plus 1 over 10,000 and so on. And this is the same as 2 times 110 plus 1 over 10 squared plus 1 over 10 cubed plus 1 over 10 to the 4th, so on. So this right here becomes an infinite series. This is going to be n equal to 1, infinity, 1/10 to the nth power. Okay, so we are going to find the infinite sum first. So this will be 2 times the infinite sum, right? And the infinite sum on the side is going to be 1 over 10, which is the first term, divided by 1 minus the multiplier, which is also 1/10. So this is 1 over 10 over 9 over 10, which is 1 over 10 times 10 over 9. So it's 1 over 9. So this is 2 times 1 over 9, which is 2/9. Okay? Okay, so next set of problem, you get 0.37373737 and so on, right? So this one's going to be very similar. So if you think about this is 0.37 plus 0.0037 plus 0.000037 and so on. Which means this is, if you think about it, this is 37 times 0.01 plus 0.0001 plus 0.000001 plus, and so on, which is the same as 1 over 100 plus 1 over 10,000 plus 1 over 100,000. 1, 2, 3, million. So this is 37, and this is going to be 1 over 100 plus 1 over 100 squared plus 1 over 100 to the 3rd power, and so on. And this right here is going to be a partial sum. And the partial sum in this case, we can see that the first term is 1 over 100. And the multiplier is also 1 over 100. So the partial sum is going to be 1 over 100 divided by 1 minus 1 over 100, which is 1 over 100 divided by 99 over 100. So the partial sum in this case is going to be 1 over 100 times 100 over 99, which is 1 over 99. So this is 37 times 1 over 99, which is 37 over 99. Okay, so a good application of the reason why a repeating decimal is written as certain fractions, and this will give you a pretty good idea of the reasoning behind it. So it's just another good application of the infinite series. So, all right, let's go ahead and move on to the application problems. All right, story problems. So first one, a ball is dropped from the height of 8 feet. On each bounce, it rises to half of its previous height. When the ball hits the ground for the 7th time, how far has it traveled? So it looks like here is the ground, right? So here's the ball right here. I'm going to do a basketball, okay? So it looks like he drops and then bounces back to half of the height. So which means if this is 8, then this is 4. And so when you go down, another 4. So I'm going to use arrows because it's probably better. And then bounce back up, half of the height. So it's 2, and that's another 2. Sorry, the random lines keep popping up because my hand is on my iPad. And then we have 1, 1, and so on. Okay, so hit the ground for the 7th time. So we got once, twice, 3 times. So we got 4 times, 5 times, 6 times, and 7th time. Okay, so I hope this picture makes sense, right? So again, initially ball drop is up here, so right, going down it has 8. It hit the ground 1 time, bounced back up 4. Then it had to go back down 4, right, to bounce the 2nd time. So hopefully this makes sense. And now let's write this out. So we have 8 plus 4, right? 8 plus 4 plus 4 plus 2 plus 2 plus, and so on, right? So in this case we kind of had to break this down a little bit because we have an action that are going up, bounce up, back up, and going down. So let's break this down first. So going down, you have 8, right? Starting at 8, and then we have 8 times 1/2, right? But how many? And this is going to be our formula right here, right? But the issue here is we need to know what the distance is, the last distance that it travels. So if we count, right? So going down, the first term is 8. The last, depending on what the bounce is going to be 8. It's going to be 8 times 1/2 and minus 1, right? So if we count it, we have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So it looks like I need to figure out the 7. There's 7 going down. Right, there are 7. So there are 7 down direction. So this is going to be. So the a sub 7 is going to be 8 times 1/2 to the 7. Okay. Now going up. Going up, we have 1, 2, 3, 4, 5, 6. So going up, right? Our first term is 4, and then our ratio again is 1/2, but our n is only 6 because there are only 6 bounce ups. So to figure out total distance, we need to figure out the distance going down plus distance going up. So distance going up, that's going to be, we're going to use our sum for the formula for the first sum of first n terms, which is a minus a r to the n over 1 minus r. So going up, you'll have 8 minus 8 times 1/2 to the 7 over 1 minus 1/2. So calculator, 1/2 to the 7th power and times by 8. So this is 8 minus 1/16 over 1/2. So 8 minus 1/16 and divided by 0.5 is 15 and 7/8 feet. Now for distance down, it's going to be the same idea. It's going to be 4 minus 4 times 1/2 to the 6th power over 1 minus 1/2. So 1/6 or 1/2 to the 6 times 4 is 1/16 also. So calculator, 4 minus 1/16 is 3.9375 in my calculator. Then divided by 1/2 is 7.875, which is 7 and 7/8. So total is going to be 15 and 7/8 plus 7 and 7/8. Okay, so we got 15 plus 7 is 22. So 22 and 14/8, which is 23 and 6/8. So basically 23 and 6/8 feet. All right. So 23 and 3/4 feet is the total distance that the ball traveled up and down. So you might see a lot of these type of problems in actually also in some kind of exponential growth. because exponential growth is essentially, if you look at it, it's the formula. It's like a geometric series. It's like the formula for geometric sequence. So that's definitely something that make sure you pay attention to. All right, last problem. Suppose you are paid a salary of 1 cent on first day of February, 2 cents on the second day, and your salary continues to double each day. How much would you earn in February? So it looks like we have 1 plus 2 plus 3, 4 plus 8 plus plus so on. It's going to be the salary. Okay, so let's check this out. So we know A1 is 1 and the R is 2, and the N in this case, because we have 28 days, so N is 28. So let's plug in our formula. 1 minus 1 times 2 raised to the 28 over 1 minus 2. I'm afraid that I'm thinking this one's going to be huge. 2 to the 28 is... This is 1 minus 2, 6, 8, 4, 3, 5, 4, 5, 6 over negative 1. So 1 minus that is, and divided by negative 1 is going to be 2, 6, 8, 4, 3, 5, 4, 5, 5 cents. Which means 2684354.55 dollars. That is roughly 2.68 million. I'll take that job. Okay, alright, so this is it for the geometric series and sequences. Hopefully it's fairly straightforward. Any questions, please let me know. And we'll get ready for the test and then for the final. Alright, good luck. I'll talk to you guys later.